So this is where I start. This system, I have to compile it using this run button. When I have the right answer, there will be like a yellow button in the bottom on next, and I'll be able to go to the next section. So here I just printed whatever, it just said print something to the console. My instructions here are on the left, and where it says instructions, I have to print something using Python 3 syntax, so just using parentheses instead of quotes. That's pretty much like one of the main differences between like everyday use of Python 2 and 3. They're very similar. So overall, I actually think that this is a pretty good, this is Python 2. But if you're just learning for the first time, this is a free way. I think this is actually really nice. And overall, I thought this was a really nice review. So even if you know Python, you have experience, it's really nice to be able to do something and really see how fast you can do it. And you can post your dimes in the comment below. Yeah. It's all a fun time. So here, there was two differences. So whenever you have a quote, another quote in like printing a Python string, you need to print a backslash in order to like escape that quote. Like if you're trying to actually print a quote, because you use quote to print your string, so it's something that can come up in dealing with text data. The other problem, I think, you just need to have your quotes attached to it. The other ones, yeah, just setting this is kind of basic variable stuff at this point. Putting product, and then this modulo operator to get divisors. So yeah, this is actually a pretty important or kind of really nifty tool knowing how to use this plus equal operator sign effectively. I think I was a little bit slow here because these string names are really long. But basically I had to type this annual rainfall and then plus minus September rainfall to October, December, just all those strings that you see there. So that plus sign just makes it cumulative, so you add like whatever that variable more that you had to the left, like you had some variable annual rainfall, so then you add January, you add July, you add all the months that you wanted. Using this plus equal, you can just say that the initial thing you had plus the other stuff. This one you just add a comment. It was just pretty much asking you to just put a comment, so it was pretty easy. But yeah, I think this is Python 2, but I think using Python 3 is you should know, because there's a lot of like times that come up that you'll have a question that came up 10, 15 years ago, and the answer's in Python 2. You should really know how to go from Python 2 to Python. It's really not difficult, honestly. So I think this is overall, if you don't want to spend money on a course, honestly, I think this is a really good one. It's really kind of nice, and the user interface is nice. It compiles nicely. I thought it was, again, a great review, and you kind of forget if it's really Python 2 or Python 3. The only thing really the big difference again is kind of the print statement. There's like a few other differences. Modules don't work the same. And worst comes to worst, you can just download your own compiler. So if you're trying to learn this for the first time, you can just like run it in Python 3 yourself. Make sure all the code, most of the code will just run the same. So that was a pretty basic problem that we just went through. I think it was just pretty much setting variables equal to each other and doing like algebraic manipulation. I think there's more efficient ways I could have done like this whole thing. Like I could have probably copied and pasted more and stuff like that. Just setting stuff equal. Print. See, I always kind of, this is the main difference again. There'll be the last time I say this, I swear. But yeah, I'll sometimes put the parentheses. I think it actually will accept it. So I think, I think I did this a couple times. The CodeAcademy will actually accept this parentheses nomenclature, even though technically that's not Python 2. So again, usually Python 2, you just have a space and then your quotes. But for Python 3, you can just print parentheses and then your string. This one I just had to, I think they didn't want that answer. I thought this one would actually work, but they wanted me to do it a certain way. They wanted me to explicitly change this. I think this is what they were asking. I was trying to do this just really quickly, but I thought they were having me explicitly change the string to be a float. So basically, when you put numbers in, if you just put the scalar number, like if you put 1, it'll interpret that as an integer, right? But if you put 1.0, and you explicitly say it's a decimal, it's a float, it'll treat it like a float. And so that's kind of important, especially when you're dealing with a lot of data and like machine learning problems. Because when you pass it like into a neural network or something, like you want it to properly, I mean, any kind of regression problem really, you want it to properly understand what those variables are. So if you're loading data and you see like a 1, it's kind of important to understand if that's really supposed to be a 1.0, like a float, or if that's like an integer, or if that's like a factor, right? If that's just represented like a yes or a no. And that's kind of what they're going through here, false and true. I think it was just setting these variables as being true or false. I don't know why it's taking too long. All I had to do was put product. I might have been already getting tired at this point. Just type product equals float 1, float 2. The problems are so long, I kind of like get lost, like get tracked of them. Yeah, this is all kind of basic manipulation. You use these plus signs to combine strings. So if you want to concatenate a bunch of strings together, but it's important that like everything you pass in, because you can't pass in, like you can't say quote the product was unquote and then add a 1. It has to be an str1. That's what. So you have to add the str product to make it a string. You can only add strings to strings. You can't add like a number to a string. Yeah, this is, I think, the last one for this problem. Just setting stuff equal. It's just kind of hard to read everything, but yeah, I mean, this one, I'll probably give a little bit more explanation for these later, but I think they were just asking me to set this. I accidentally opened up my JavaScript here, but I was in the zone. I didn't want to close it, so I wanted to compile this, or I think I finished writing it, at least. No, it's just like if I have points, so many points, and I just have some algebraic manipulation. Last thing is you're adding the string, and you need to explicitly make sure that this x part, you guys do a str string. What did I do wrong? Oh, I forgot to put the exclamation point. No, something else. It's always interesting, so I always forget to. The space, yeah. It's always something small like that. I didn't put the space between the points and the other one. I didn't know that it was asking me. I was kind of confused. A couple seconds there. All right, number 2, so on to strings. I had to say Brian was equal to hello live. This one was kind of like just kind of linguistically, I don't know, it kind of got my brain crossed a little bit because you had to set these names equal to like different strings, and I was like, oh, okay, what name was it again? Or just typing them as quick as I could. Just basically, when you put the quotes around it, that makes it a string. When you don't have quotes, you're pretty much referencing a variable. You need to be kind of careful you'll see I'll do this sometimes, but there's certain, like, you should try to be kind of unique with your string names. I'm not really that good at it because I kind of just, my string names really aren't that good, but you should try to be unique because there's like in it and like you don't want to say int or float or like print. You don't want to call a variable anything that's like a Python thing or function or object or something because you'll start getting into problems. That's like the source of like a lot of problems if you're not careful about what you're naming them. This one I was kind of confused what they were asking at first, but they wanted me to say I had to explicitly, not just the fifth one, I had to explicitly say like the whole string, monty, and then type at the 4 at the end. I think it actually took me kind of a while to figure this out. Hopefully not too long. Yeah, no, not too long. Sometimes it's kind of hard to say what they're asking. I started using some really long names like Norwegian Blue. Probably could have copied and pasted them, but I just typed it out. I didn't need to type printed. I should have just put parent equals that, but I didn't really get that. Type dot lower. That's kind of helpful, yeah. The case, because like especially when you put into like neural networks or like for NLP projects, like or even like Word to Vec or anything, you want it to be like lowercase or uppercase. So you usually want to put your input data as the same case. So knowing that explicitly passing like upper or lower. You pass the string, you like other attributes, like you just say dot and then parentheses within there. So like again, you type my object, my variable object dot upper. This one's letting me do the Python 3 syntax. Honestly, you could have probably just done Python 3 for 95% of these, and it would have still run. I kind of forgot I was doing in Python 2. Pretty basic, just printing the variables. The upper thing that's kind of repetitive. Knowing what the kind of like what they're really asking you is kind of part of the problem, right? I think this one, did I get this a little bit? Yeah, I needed the spaces here, so that's another thing. Like you need to whenever you're trying to make something especially readable and you're like concatenating together, you're always gonna have to make sure your spaces are correct. Like your spaces don't. I don't know, maybe it's like a mental thing, but for people, it's like kind of hard to at first when you're like not used to it to make sure, when you put add, you need to add spaces as well. Those are like something you need to add. I guess it's pretty obvious. Maybe it's just me. Probably it's just me. This one, yeah, we had to replace this. So this is one of the actual other differences between Python 2 and Python 3. So in Python 3, they use f strings, and that's kind of the way that they do that now. And I think they're supposed to be more efficient or something. I honestly don't know too much about them, other than how to use them. But like for these, you have to use these parentheses or these percent signs, and these just reference like those are just placeholder variables. Pretty much, you just push that percent sign s in the middle of your string, and then the order, you can have as many percent sign s's as you want, and the order that it comes across them will be the same as like the variables that you explicitly pass. So you'll say like percent sign s, percent sign s, percent sign s, and you'd say like, okay, well I want that to be month, day, year, or whatever whatever date format you want. So it was the second one. Having fun here. I was feeling pretty good, I think, at this time. It's exhausting. It was pretty exhausting to just try to code for 2 hours straight. as fast as you possibly could. So this is there's this date time. You can just get this time. It's basically, this is kind of goes more into detail about formatting strings. Dates are really kind of popular topic for learning how. I think if you know how to like kind of manipulate dates pretty well, then honestly it's one of those underrated sort of topics that are kind of like difficult because they're formatted so many different kinds of ways, and like explicitly declaring them, and then sometimes they have time data, and sometimes you know, they're very you have to be careful when you're working with dates. And generally, if you know how to manipulate these dates, you can say feel pretty good about your ability, to work with strings more generally in Python. So yeah, you just save this. So I'm saving this variable now as like a datetime object. And here I'm pretty much copying and pasting from their description. But what I need to do, so we just are putting the dash. So the D, so that's like the percent sign S, for this is percent sign D. That's just changing like the format of the output. To be honest, I don't exactly remember what it is. I'm pretty sure it's like integer to string or something. I just use it because that was the same one that they provided. But basically, yeah, it's the same sort of idea. You put that sort of structure within your string. You say print that, and then you put the percent sign, and then you put your variables after that in the order that you want them to be referenced. So like this one, I copied that, and then I'm adding the H. So I'm adding the hours, the time. So now I have twice as many. So I have the percent sign D, the percent sign D as before, 6, and then I also have 6 variables, and that was what we needed. So this next one. So I think I probably should have, I was thinking about this, I forgot, I should have been more careful. I didn't exit all those notifications on the right until later, so. This one was, yeah, well, you had to like, it was weird. You have to read the comments, and then it was just kind of like logic puzzles, I guess. But I guess it's just supposed to show you can set variables to like true or false or other like Boolean values, which is 1, 0, like things that are just supposed to be 1 or 0. So that's actually kind of helpful in data science when you want to like when you're loading data, especially any kind of label or output. Like if you say something is, like if somebody has a disease or doesn't have a disease, it's like a 1 or 0. So that's the kind of output. Again, if you have a 1 or 0 there, you would want to make sure that you're treating that as a factor and not as like an integer or a float or a string even. And sometimes you want to treat it like a string if you have 0, 1, 2, 3, but then those are just classes where there's no difference between, there's no meaningful difference between like 1 and 2. I didn't know what this was. I wasn't really sure what this was. I just kind of kept on pressing. I was trying to see how fast I could do that. This one, yeah, so you can have like multiple Boolean operators. I didn't really understand this, so we were just supposed to copy these, I guess. Same thing. It's helpful when you want to like check multiple conditions. So you can either usually like put a single for loop and like, or single if statement, and then you could say if, and then else if, and then else if, or you could say this and this and this is and this is not and this is not. So you can use and as condition if statements. It's kind of just efficient, but you can also, and I mean, everybody does. Everybody kind of has their own way of coding. There's, I think, different ways that are more efficient. But there's like an efficiency computationally, an efficiency that comes with like how easy it is for you to actually code it yourself, and the labor that you have to actually do, and how much you're actually going to get out of there. That was me double checking that I was still recording. Yeah, this was just like kind of me thinking of. So I knew you had to do a specific combination. I didn't know like what kind of requirements, but I figured out that they didn't want you to just say like 4 was less than 3 and then 5 was less than 4. You had to like kind of flip it up and be like it was greater than or equal to or less than or equal to or whatever. So I just was kind of, so you have to use and or not. I spent a little too much time on this, but yeah, just again, those are helpful for just generally like checking multiple conditions kind of efficiently. I didn't, yeah, actually. So I just said that it was like, I just figured that it was too much to read, so I just kind of print it as Y. Yeah, I think I remember should have reading this or something. I was confused. I didn't know why this wasn't working. Oh yeah, you have to set response equal to Y. It was at the very top. That was, yeah. I should just went there. I didn't even know. I should just gone to the very top. I bet I wasted some time. It's fine. Obviously, this is not going to be. I'm pretty sure a lot of people could do a lot faster than me, but I always want to see how fast I can do it. I kind of push myself. So yeah, so this one kind of tripped me up. All I need to do is put return false on each of those. But this is basically saying you can, yeah. So these kind of Boolean statements, like you would return it. Let's say you want to make some condition, so you would write a function here. You would say like def Black Knight or def French Soldier. You'd say if the input of your function is whatever, then you could return true or return false, and that's a way to kind of check. It's an efficient way to kind of go through. It's all about efficiency, really. Like for everything. Like what I mean is like that's the kind of the point of like doing anything with the computer or like programming at all, right? But it's also how to make it as good. I'm definitely not the most efficient programmer. Um, I tend to kind of favor how easy it is to write it over how computationally efficient it is. It's kind of not the best habit I have. So here you just, yeah, so this is like, let's say you want to define a function that will check some object, and basically all you need to do is say like def. So this def is just saying you're defining a function. This is the name of your function. In this case is grade converter. Grade converter is going to take in as input this grade variable. You can put a comma and as many variables you want. What this grade converter function is going to do is going to check if it's greater than 90 or between 80 and 90. And I think I got to flip the signs here, but that'll return value. So the returning value comes from You know, basically that just means the function is outputting. So the difference between like printing and returning is like returning is what the function actually has, is like kind of what the function is contained by. It doesn't actually print out, like you don't actually see it. It doesn't print out. It's not like printing is just a very visual. Think about it like visually. Returning it means something internally. It's like it means something that information you could set a variable by returning it essentially, but not really by printing. It's just a visual thing that prints it to the console. That was something I have a hard time understanding when I first started. Well, it probably wasn't that clear just now anyway, but so here we use this raw input. Raw input's like a thing. I've never actually really used this. I bet some people probably use this. I don't. It's just not, data science is not one that uses these inputs, that requires like explicit user inputs in that sort of way. But it's fun. Yeah, basically just, you know, programming it, asking for an input, and then we check if the length is greater than some value. So yeah, those conditionals are just helping us check, and then we print it out. Otherwise we print empty. Yeah, so I have to go. I had some like glitches with the thing on the right side, like trying to do it quickly, I think made it freeze up. And then I had to like refresh it a couple of times because it has to like actually interpret all the way on the right side. And that was like, I don't know. I don't know, that it just didn't accept the inputs as quick as it should have. So here, yeah, I'm checking not only, you could say your if statements as an example would be kind of efficient using those ands. You could say like and not. It's actually kind of like you can kind of do a lot within the line of a single if statement. You can put like and not or but not. Like it's like like when I first started, I kind of was like very surprised. I was like, you can just like write like you're writing to like a person almost. You could say like do this and not this, or but not this. I guess if you speak English, it might be speak like English natively. It just seems very intuitive, but yeah. Here, yeah. So this one was kind of, I guess it just took some time. I was just kind of going through it. We're just setting strings. You can subset strings. So like if you have a word, you can just treat it like a list, the same as you would a list, which I guess we'll go more a little bit in a second. But you can just reference the first one, like as with the bracket, say 0, bracket 1. Then you can add everything together, printing this. And a word, and then I think it took a little bit of time on this one because I really wasn't understand. I thought they were expecting to set it to the actual slice, like the actual command or something. I think that might just been a mistake on my part. Well, obviously it was because I didn't understand it when I first kind of read that. But basically, they were asking me to set it as that as a new word referencing that one. Yeah, so I was waiting. I need to just put new word here. Yeah, and that needs to have an underscore. And then I need to keep, okay. Let's see. I think, yeah, this one was just run it, whatever. So you can just get to the next step. You're supposed to play with it or whatever. So I got to the next one. So it's just defining our functions. I just made, so you have to put the parentheses. So yeah, you just say define, that's how you tell a function. If it doesn't have anything in parentheses, it doesn't take in explicitly any inputs. I wanted us to add a comment there too. This one was just taking a while for some reason. Here we need to just replace these arguments. So yeah, at the top, if we have a function, we would put in all of the arguments, everything that we want our function to input, where the underlines are. I didn't do it, but I'll do it in a second. And just so it's like everything, all the variables. So when you put that def and then that function name, in this case it's power, and we're going to take in a base and exponent. And so those are the only variables that we can use inside our function that we don't have to explicitly define. So if we don't put anything in that function, so in this case we have one good turn in, the in is the only variable that we can use without explicitly defining it within the function. And so that's what this case, and so this one is asking us to, and so for this, so we can output this function, pretty much that's, again, like this return statement. But we can return, the return statement is going to be kind of complex, and we can even reference other functions here. So here I'm going to reference one good turn within that function call. Here I have a function cube, takes as input number, it's going to return the cube of the number, so it's just times 3, or that number times number times number, raised to the third power. I think I needed to say define a second function by 3 that takes as a number, as input number, and then it returns, I should do an if statement, so if statement by 3, if 3, so I should have done number, I think I get that mistake, but this should have been if number modulo 3 is equal to 0, I return the cube of number, which is that function. So you can see how you can reference these functions within your functions. And so it's important, especially to reading, if you're trying to kind of look at a GitHub, especially do something like state of the art or really complex, you need to really understand and kind of be reading through all these functions, and you'll see that they'll have constant cross, they'll call other objects or call other externally derived functions. So it can get pretty complicated. So that's it. They're just pretty useful, or it is at least used a lot. It'll be a matter of time. I think right here I'll probably get it. I just need to replace that with number. Okay, kind of taking a while here. There you go. So this one is asking me to, I think it's asking me to get the error or something. And then I have to import math. So this is something that SQRT and there's a lot of other ABS, SQRT for square root, ABS, POW, POE, EXP, Math EXP, Math POW. there's a lot of these math formulas that you have to import for a lot of these, a lot of functions. And so, like commonly, like when I first started, I would always run exp or pow or something, and I would always forget the to put import math, and then you have to actually call it from the math object because those aren't really Python. Max and min are actually ones that you don't have to call math for though, because the max and min are like Python native, or they're within Python. They can work on lists, which is kind of helpful. So like you just want to find the max or the minimum of a list. So like for normalization, like you're trying to normalize a data set. Apps, yeah. I'm surprised you didn't have to put I thought you would have to put the math apps. I think you did. Oh yeah, because I imported all of them. Yeah, when you import objects, you can either say like from math import just what you need, and then you would say math dot whatever you need, or you just say import math, and you would get the same thing. And you don't. The other one's faster because you don't want to like just download every single submodule that you might not end up using if you just need that one or whatever. You see, yeah, just defining function called shutdown, takes in s as our argument if s is equal to yes. So the double equal sign, the difference between the double equal and the double equal sign will actually check if there's essentially, so double equal sign will give you like it'll check if that's is equal to that, and equal sign is just implying that you're actually setting it equal to that you're changing the variable or whatever. Yeah, so just printing, this is all kind of gone over this. I need parentheses there. Type is kind of helpful. So yeah, again, like whenever you're loading a data set, not only do you want to make sure that like if you load a label, that's like a label variable and not like a float or something. Whatever you give it is whatever it's supposed to be, essentially, the right data. But you also want to make sure that if you have like a single column or single data vector or structure, that everything is what you want it. Like sometimes if you give it a bunch of strings, you give Python a bunch of strings, and one of the strings happens to just be the string one, like the number one of actual numeral, it'll load that as a integer while everything else it loads as a string, and then it'll kind of throw errors once you try to like train models or something. So it's something to keep in mind. So this one, yeah, so we're just need to write a function called answer, so def answer, and that takes no values, but still needs some parentheses that returns the value that we want, 42, no matter what. So now we're making another function called hotel cost, takes as input nights, and we put our parentheses and our colon. We're going to return hotel costs times, what would we return? Nights times 40. 140 times nights? Yeah. So yeah, I actually probably took a little bit longer for this. I should have just typed it out, try to kind of outsmart it. Well, we'll see. So yeah, so now I need to say conditional. So this one, I should have put if city equals Charlotte, then return 183. If city equals Tampa, return 220. I tried to make like a dictionary first, which is probably, honestly, it would have been like the more quote proper way. Obviously, for the speed run, I think it wasn't as good. I should have just done it the way that they wanted me to. Um, that's not what they wanted me to do. So then I had to do it the way that they wanted me to do, which was to call these. So I'd have to say like check each individual one. So I say if city equals Charlotte, return whatever. And it takes me a little bit to get through. What I was trying to do is put in a dictionary, which would just like reference the city. I really like dictionaries and lists. It's really kind of useful and maybe just the way that I think. So whenever I get a chance to use dictionary, basically it's just, if you think about what a dictionary is, just a key and a value. It's literally just a dictionary. But the powerful thing about dictionaries is that they're not just like words, right? They're not just, if I look up a word, it's just a word. They can be lists or they can be dictionaries themselves. You can have dictionaries of dictionaries. You can have dictionaries of dictionaries of dictionaries. You can have dictionaries of list of dictionaries. You can kind of have, very, very, very interesting structures that should kind of make, life easier when you're doing a lot of these problems and just really helpful. So yeah, so I say if city equals Charlotte, return that. If city equals Tampa, return that. Took me a while to type that. Now I have to say if the city car, so now every day you rent it is $40. You get some. If you rent it for 7 days or more days, you get $50 off your total. If you rent it for 3 or more days, you get $20 off your total. So yeah, so I just said like yeah. I actually kind of did. I kind of feel like I thought I did this kind of cool. I basically just said if the days was over 7, I set the initial cost to not minus 50. If the days was over 3, I set the initial cost to minus 20, and else I set the cost to 0. And then I just add the number of days to the cost that I would need to do times the amount per day, the $40 per day. Yeah, so this one's just calculating a bunch of different functions, and I'll add another function to put them all together. This is kind of how these really big Python packages work. So yeah. When they upload them on GitHub and stuff, you'll reference what will happen is like you'll see the name if it'll say trip cost. So if you look at a GitHub, you'll be able to, if it'll load a function, and you should be able to find that function. If it's not explicitly defined in that document, it'll be defined like somewhere else in that GitHub. So especially if you're interested in learning like a given, GitHub project or something, or code, digging into the files to find the functions that they're referencing. Because the functions, like what I mean, like the functions are actually the file, like the Python, they're separate Python files. So you don't have to just have load functions within the same, like here, because you have this compiler, right? And here in this case, in CodeAcademy, every single function that you call, you'll define within it, except for like math. But like you're not really importing any other functions. But when you do like a real project or whatever, you'll be importing functions that package will have, so you can actually go through, and that's a really good way to actually figure out how these packages work. And so this is now I'm writing a function to combine all of these. You see that I have like 3 inputs into my trip cost function. I'm returning calling the function for the rental car cost of days and the hotel cost of days minus 1 to find out pretty much if I go to this city or whatever, how much it's going to be. That's what we wrote. Pretty cool stuff. I think I was probably getting pretty tired at this point. But you guys aren't tired because you're very excited about learning some Python. Or you're excited to laugh at me at how bad I am at Python. Either one works. This one we had to put our favorite animal. I put pandas, even though I could have just put like any string. I had to write it out. Felt like I had to. So when you're dealing with lists, so I think this is now, we're talking about lists. Lists are pretty nifty. They're just, basically lists. You identify, and they can be, again, lists of lists. You can have lists of strings. Your strings can be anything. Your objects can be, like, they're very variable, so it's kind of nice in that way. And like a lot of, a lot of the packages that you'll use, like pandas or NumPy or scikit-learn or PyTorch or TensorFlow or whatever, they'll all use like these kind of native Python objects pretty well, and if you know how to do it right there, you can do a lot of cool stuff. And so similarly, it's like some kind of list comprehension objects. So to identify, like if I have a list of these 4 animals, you would just say bracket 2 or whatever, bracket 3 that would reference. Obviously, it's indexed at maybe not obviously, but it is. Python is indexed at 0, so you start at 0. So if you want the first thing, you have to say 0. That's just something that kind of comes up a lot. Probably came up already a couple times. Length of the list is pretty nice. So lengths of lists are pretty nice, especially in like data science, because that will tell you essentially your population size. Usually that's kind of the way that you would identify how many samples you have, how many features you have. That's used for like a lot of normalizations and all kinds of fun stuff. So you can, going through lists, you can identify specific segments of lists using this colon, like 3 to 5, whatever to whatever, 5 to 6. I think I kind of just tried a couple of them. Probably should have been more careful, but I was just kind of trying stuff until it worked. And there's this part. So when you have like a single string, so you can actually treat strings pretty much like lists. Like you can iterate through them. You can say like for I in string, you can say like reference the first one, like the C or the A. Like in this case, cat, dog, frog. You could say like for I in this case animals. They would iterate. First thing it would be a C, and then A, and then T. So it's just like you can treat them the same, which is kind of helpful for like especially like DNA and stuff. Like if you want to go through a sequence of DNA, for example, you could just say for I in sequence, and then every single I would be one of the letters, just like a list. And so it's pretty helpful. But also it can be helpful, but also can be kind of a pain too, because like Python will just let you just do kind of nonsense. Like if you're not meaning to make that a string, you can say for I and J, thinking that you're just talking about some list level when you actually are like one level lower or higher than you think you are. And you end up iterating over not your list of strings, but over a single string, and you end up kind of getting something wrong there. That's happened to me before too. So it's like, while you can't, it's kind of nice that you can iterate over strings just like list. It means you can kind of do like weird stuff like iterate over strings like list, which you might not necessarily, it's not going to throw an error or anything, because you just can't, it may make sense, but it might not be what you're actually trying to do. So these taking kind of bread and butter stuff here. When you're you can take lists as inputs of functions. Here we're saying for I in the list, this is what, a very common command. For everything in this list, what we have at the top, we're gonna square list append another list. And that's helpful, especially because you don't want to always just like delete the old list you have. For example, if you just want to make like another list, another copy, you have a list of strings, but you want everything to be lowercase. The easiest way to do that, I think you can just pass like a lower function, but usually because it's so like it works for a lot of things. What I would just do is just essentially say like, for I in list 1 of what I was starting with, and then append a lower of that. Basically, just operate on every single element and then append it to the other list. And it'll be the same size, and you'll be able to do that and keep the original list, and that's important. In this case, starting to work with dictionaries now. So dictionaries are basically, you would say, so this is like the kind of simplest dictionary. So you would pass it the key. So they're defined, you'd say like menu, you have to define it as a dictionary first. So you say these brackets. And then you would say the key, in this case chicken Alfredo, is equal to 1450. So that whenever you type chicken Alfredo menu, man, this is making me hungry. But when you put the chicken Alfredo there, it'll pop up with 1450. And the reason, so like this is it makes a lot of functions very efficiently, because here's what you can think out, like especially if you have a data structure that like if you have the example of locations or something, you have some measurement for every location. In order to identify and you want to make a correlation, you have another list that is correlated, representative of that single one. You want to use a dictionary and not a list there, because basically what you're saying when you use a dictionary is you can identify specifically, instead of having to go through every single one. Like you can just identify, say, oh, I know that this is in this location, so I don't have to go through this whole list until I find it. Because there's certain problems that you're going to have to go through the whole list until you find the answer, but there's other certain problems that you're going to be able to make a lot more efficient. And the way it always comes down to having a sort of key. If you can think to yourself and you find that sort of key in your data that says, I know where in my data this is because I have this key, this reference value, you can use this sort of dictionary, and that will make your life a lot easier. And honestly, there's like, it'll make, certain kinds of problems will make them like days more efficient. And so it's really important, this is a really important, powerful tool to keep in mind when you're doing really any kind of Python work. Honestly, if you're working with Python or all these dictionaries, like certain tasks, you can do them with a list, and there's ways to get around, and they're kind of, they can even be pretty intuitive ways with like a list to do them pretty quickly. But if you're you really want to make sure you know when to use a dictionary. And so here's like a great example too. So you can have very complex dictionaries. So this dictionary here, this key, and the keys each means, so gold is one key that means 500. It means an integer of 500. Pouch is another key in the same inventory dictionary that references a list of 3 of these objects. There's another key that references a list called backpack of 4 of these objects. And so you see how, and you can operate on those, you can call inventory and call that pouch list and operate on that list, and you can define other keys here. And so, yeah, basically, they're very versatile, powerful objects that not only can handle sort of like very interesting data structures, and that are helpful for when you're trying to, like basically when you're trying to actually to be efficient with how you're storing them, but also how you're actually operating them over, because they can be very useful for identifying very specific parts of your data that you don't have to actually search through your data. And so those are pretty helpful. Let's see, what did I get wrong? I'm not sure what I got wrong here. Oh, I didn't take out, I put the underscore under strange vary. All right, so what is this on? This is about for loops. So, so you can iterate over these lists, like, so you say for I think I already went over this, but for I and this are these lists. You can also iterate over the keys of a dictionary, which is what this is doing here. And so you could do it. I think there's another way that they actually introduce it, but this is the way that I usually do it. So for I in this keys, you just say dictionary.keys and then the parentheses for I in that. And then that's your way of iterating. And then you have to make sure you reference that. So for I is the actual key. So if you want the value, you have to say dictionary bracket I to get your actual value. So this is a list. What am I doing here? I think I just if it's modulo 0, I'll put that. This one, I'm just writing a function that takes into account this x, and then for item in x, if x is equal to this string fizz, we will increment the count variable. Yeah, I guess another example of for item in x. Yeah, if I have a list of strings, so like 3 or 4 strings that have fizz in it or whatever, I'd be able to count however many, iterating over those strings and then making that operation, putting that into a function, I guess is what they wanted us to do there. So now we're trying to make this store apparently. We have the prices. I kind of copied the format that they had for that zoo just because of the readability. But then I actually, I guess, end up copying it there. And just having that. Then I do another one where it says stock. And then I'm going to do the same thing. Just define the dictionary. So yeah, so this will be helpful. So instead of like having to search through these lists of price and stock until banana is equal to banana or whatever, I can just make these dictionaries and sort of take this dictionary approach and identify that if I know banana, then I should be able to find the other one. And obviously a lot more efficient. So yeah, iterating over these price dictionaries, price.keys. So yeah, you can't, when I first started, you kind of got confused with treating dictionaries as lists. You have to convert, you kind of have to think about them like they're the keys, or in terms of their key value. That's kind of like the reason why they are. Again, we're using this this percentage S nomenclature, which is kind of similar to the F string. That's kind of more popular now. So basically, you just like put F in front of the quotations, and then you put your value at the end similarly, instead of the and then you put like parentheses, and then you put your like percent sign F or whatever. Here, yeah, so we're just going through these two dictionaries. So we say for the key, I was actually not sure. I don't really ever do it this way. I would have said the same thing where I usually do the for I and dictionary.keys. Go ahead and do that. Start my total beforehand and print total afterwards. So now I'm making a list with groceries. So I just start in groceries equals this list. Defining each of my, just doing that. Shopping list equals that. And then we're saying defining a function compute bill. So we'll say def compute bill takes into account food. Where total is the initial value of 0 for each item in the food list. Add the price of that item to total. So I'd have to say, so I'm iterating over the list of food. I would say total equal food price return total. Is that right? No, I can't be right. Oh, I didn't get the last part, so I need to. I need to. Yeah, this one took me a little bit. I remember. So it was asking me to say if the item is in stock, and after I add, I have to take. So it's like if it was greater than one, then I have to actually charge it and increment the stock. But I remember getting this wrong. It took me a little bit to get wrap my head around this because I was doing it backwards. I was saying only take it from the stock if it wasn't there, which obviously doesn't make sense because I should have put it in the other one. So you'll see me struggling with this. Um, yeah, I'm not perfect. Never said I was. But we're trying our best here. We're getting it done. We are working on it. I think this is when I started getting pretty worn down. Yeah, it's still alright. I think I was still okay. Yeah, it took me a while to get this. Um, Again, basically, I just had to recognize that I only decremented the stock when I was underpriced. Yeah, so I was originally talking and had some audio, but I just decided to mute myself because I hated the sound of my voice. Uh, I thought that maybe this would be better. It's not, but any day now. Well, at least I'm closing I figured it's not going to take me much longer. I run it again for the third time without changing anything as if that's going to help. Real smart, looking real good. Definitely looking like I know what I'm doing here. At least see, this is how truthful I'm being, is I can't be cheating, because why would I make myself look this bad? I think, oh, there I go, I figured it out. I think I figured it out. There we go, I'm gonna finally just throw a pass in there. So you throw passes, so it's like there's differences between continues and passes. Um, Basically, their way, if you want to just like have a function that, like, you can't have an empty else statement. So you'll throw a pass in if you want to say like else, and then you don't want to do anything else. You just pass. It's like have like a game, right? You're just gonna pass your turn. But that's different than continue, which is like continuing on. Obviously, it's different than break, which would be stopping whatever your flow, your conditional flow was. Let's see here. So now I have to define some more nifty dictionaries. Defining them with quizzes, homework. So it looks like we're some teachers now. I decided for Ellis and Tyler, and it's asking us to actually set their name to their name. Took me a little bit to read it, but we'll get it eventually. Alright, so then it reformatted it for me anyway, so now I just need to I'm going to copy and paste that. Again, so yeah, this case we got 3 dictionaries, each name. You could even, I think that they could have defined this as a class. It kind of would have been pretty high, I guess, higher level, but you could have just said that this whole thing would have been a class which consists of these objects. But they're saying dictionary, that would be like a student class, a student object really. But each of these students consists of a dictionary, and then they have a name attribute, and the name is a string, and they have a homework, quiz, and test attribute, which are lists. And then we're defining a list of these dictionaries. So now we have students equals the list of these dictionaries. And then we are going to print each of these names and print. So yeah, this isn't right. I should do name. I should do like, what would it be? Yeah, I and then bracket name. Yeah, come on. You'll figure it out. You will figure it out, won't you? Won't you? Eventually, you'll figure it out. I know. I believe in you. There you go. You got it. There you go. All right, so now we're going to define some functions that are going to take as input these dictionaries of lists. So at this point, it really does kind of become like very similar. At this point, everything is going to kind of just branch off and be a little bit more complex versions of these. But basically now we're defining functions which do, get progressively more complex and have progressively more complex inputs. And we're using sort of these same basic data structures from lists and dictionaries and building until we can do really interesting things. So I was just taking into account, writing a function that takes into account a list of numbers, counts the numbers, finds the averages, returns the averages. We're doing another function that's actually going to get the average for a student, which is just going to call the function we just wrote for the average for each individual student, or for the student name. So I'd have to put like student name there. Name homework, yeah, that's right actually. Oh yeah, so this is quizzes. So yeah, say quizzes is the average, is that average of the homework average of the quizzes and the average of the test. And then that's a weighted average, so we're gonna return their weights times the values that we found. Good stuff. Good stuff. Good job. You're doing great. You are doing great. You are doing fantastic. And now we want to check what their grades are and get the actual letter grade. So we want to say def grade, letter grade. Again, define our function, define what we're inputting, the score. We can return to all sorts of things. We can do whatever we want because we're pretty good. We're pretty cool. Just sneezing. Maybe I was headbanging. Actually, wasn't sure. We'll leave it as a mystery. Score is greater than 80. So in this case, I kind of cheated. Probably not the best way to really do that, but I just said if, because it's sequential, right? So if score is greater than or equal to 90, return A. And then I said right under that, else if score is greater than or equal to 80, then return B. So that it would always be, that is really only going to be between 80 and 90, because I'm already going to go through the first conditional first and then say if that doesn't pass that, if it's not greater or equal to 90, then check if it's greater or equal than 80, as opposed to explicitly passing out. Usually I feel more comfortable explicitly passing it out, just to make sure that there's no like slips. Like sometimes you can write a conditional and something might not, especially if it's like, again, not thinking like the right float, or if it's a integer, or I don't know, whatever. You just want to explicitly make sure that what you're passing and what you're calling a label and what you're passing is like what it should be. So now we're getting class average. Yep. So now, we've passed function on function on function, pretty much combining everything. So now we'll say, this is another kind of common thing that you do. You say, like, lists are really helpful for appending results. I think like even PyTorch and TensorFlow or whatever will use lists to append like their accuracies or whatever. Just like if you have any kind of like ongoing process, like something that's like happening as part of a loop, you would just make a list and then append whatever is ongoing to there. It's a pretty convenient way because appending to a list is pretty efficient. Searching, so yeah, if you're trying to search for something in a list, that's not efficient. You should use a dictionary. But if you're just trying to append something, lists are pretty efficient. Appending meaning you're just like adding it to the end. You could just type list.append. So yeah, in this case, you see I define get class average. I take in a class list, define results as an empty list. Then and then when I run a for loop for student and class list, I append my results for there. And then I'm not sure, get class average. What do I need to do? Print. Do I just need to print it? Yep. Determine the letter grade for the class average, and then did I just print? Yeah, I think I might have just cheated. B. Yeah, I just printed B. I guess what I was supposed to do. Just literally print B. I don't know. It works, so we'll see. We'll keep going. All right, so yeah, so speaking, this is kind of, I guess, a good segue. I was just talking about appending lists. So now we're talking about like kind of manipulating lists, and so things like, taking elements out of lists. This del operator is pretty useful. You just type like del list A. You can just reference a list, or you can say dot remove. This one took me a while also, I remember. I think this took me an embarrassingly long time. I was kind of aggravated about this. I remember this. I still, to this day, or to this hour, I do not know why exactly this one took me so long. The problem was, what I was supposed to do was just replace the second one, which I didn't get because that's what I did. I felt like I just kept on doing things until they worked, but I kept on doing the same thing, so I'm not really sure why it actually finally worked. But I was supposed to replace in1, which is the second object, the 3, with 5 times in1, which would have been 15, which I did, which I read. Oh, well, now I was running it twice. See, well, now I'm not. Just remember how aggravated I was. And then I was asking, like, did you remind? Like, I didn't exactly understand what the error was. We'll get it eventually. Okay, so I actually looked up ahead of time what the problem was. Turns out the problem is I'm just stupid. But I will tell you in a second because there's going to be a decent amount of time before I get there. So, actually, you know what? I'm not even taking the blame for this. I think they are at least partially to blame for this. And if I have one complaint, I really enjoyed doing this structure. I thought CodeAcademy. So I just got to go ahead and might as well. This is a good time since I guess we have time anyway. CodeAcademy it'll be about like one or two more minutes. One more minute. CodeAcademy, this is what I started with about 6 years ago, and they really helped me, get started. And now they're starting to. Everyone I did it was all free, but now they're doing a pay structure. But I have no complaints about my time with them. I think that they are. I obviously feel like I learned a decent amount, so I think they worked out pretty well. But basically, I should have just said print in instead of print in one. That was it. Okay, that's why. And it took me a while to figure that out, but we'll get there eventually. Yeah, I think it'll take me like another 30 seconds, excuse me. That would be pretty bad if it was 30 minutes. But yeah, I did it. And you can see my relief. I'm complaining. You don't want to listen to me complain. You already listened to me complain enough, so that's definitely not what you're interested in. Now I just want to append this for. Working with lists again, you would like go through a function for I and whatever, append your results or whatever you're trying to keep track of. It's definitely very useful for a lot of different things.
You can have this dot remove, which works out pretty well. Del is a very similar one. Del also works with like pandas data frames, so you could delete entire rows or columns, which is kind of useful for like sort of data science related stuff. Yeah. Adding functions here. Just writing functions, yeah. Def function name takes as input s. What do I have to do? Concatenated in s concatenated with world without a space. Yeah, I'll just add that. Pretty easy. I think it's just asking me to run this. It's fine. So it's asking me to return. Yeah, instead of just this is the problem that I didn't realize that they were asking me. They didn't want me to just return the thing that I had changed in that previous problem that one took forever. They wanted me to return the entire list, or vice versa for the other one. But here they want me to return just the thing, and so that took me some time, but you can do these sort of things, and yeah. So once you can pull out the best iteration, you can change it. Like if you could just assign the list of that variable as just its own object by just typing like x or whatever the name of the list is, and then bracket the index, and then that equals whatever else you want it to equal. I wasn't really sure why I had to append 9 to this list, or I had a function to append 9, but I thought that was kind of weird. But usually you would just say, append 9. You wouldn't like write a function to do something that's like the same, right? Like what I mean is like constant. The whole point of doing a function, at least to me, is that you're calling it multiple times. So you should use some kind of variable. So that's why it was kind of weird. Is this the other one? Is this the? Yeah, this is the other. I think this is the one that actually completely broke me. I start ending more soon in a second, but basically they wanted me to do this a very certain way, and I didn't understand that. They wanted me to copy and paste that because I have to delete the part that says for I in range and delete the part that says print in, but they want me to use that same syntax to actually do the problem, and which I didn't know. So I actually had to look that one up. I don't care if you don't like that, because to be honest, I did it correctly. I coded the Python correctly. We can fight about it. I don't really want to fight about it, but yeah, so they wanted me to do it, but so that there are two different ways. So basically, like there's two different fundamental ways you can iterate over something, usually, like a list, right? So for the first way that you would iterate over a list, you would say for I and this is me looking up why that problem wouldn't work, and then discovering why that there was actually an error with the exercise. It seems to be an error at the exercise is exactly what the first word. So you can look that up if you don't believe me, and that's what I'm blaming. But basically, the sort of error is basically they wanted you to say you can iterate over something by saying for I in the range of the list. So you're either iterating over the index, so you're saying 1, 0, 1, 2, 3, 4, 5, 6, 7. Or you can say over that list. So for example, let's say I have a list of red, blue, and green, of the strings red, blue, and green. So first element is the string red, string blue, string green. I could either say color, that's the name of the list, is color. I could say color 0, 1, 2, and that would be referencing color 0, color 1, color 2, which would be blue, and I could iterate pretty much over using the index and say index and then referencing that, or I could just iterate over the actual words, and so I could say for I in colors, in which case I would reference the string red, blue, and green. So it's the difference between, so for I in range and the length, so this is what it's doing here. This is what I did, which was not what they wanted me to do, but this is what, it's effectively the same thing. I was iterating over the actual list and saying, pull out each individual element. They wanted me to iterate over the indices to say the first I would be 0, the second I would be 1, the third I would be 2. And so that's a fundamental thing. Then the reason, there are reasons to do both. The reason to iterate directly over it, to say for I in colors, which would be, again, I equal the string red, the string blue, the string green. This is me looking up the answer. But pretty much, yeah, finding out that they wanted me to do it this other way, not that way. But so they want, so 0, 1, 2, and that's helpful for like the iterating over. If you have two lists that are coupled, so let's say I have a list again, like if I have a list of I don't know, attribute 1 and attribute 2, like basically, yeah, and I want to keep those together. Like I know that the index that the index out 0, the fifth element of attribute 1 is the same person as the fifth element of attribute 2. I would want to iterate over the indices so I could keep track on both of them at the same time, and I could reference both of those lists. I don't know if that's entirely a mixture, but that was a different way of doing it. So I did catch on that was how they wanted me to iterate over the actual indices here, and so that's what we worked with. Yeah, just defining this list. We have a list of these values. We want to define a function that's going to double these values. But this is the contrary. This is what they wanted me to do. They wanted me to do it by referencing the indices of these lists. And I'm kind of talking to no one. They didn't like my audio. I should have just focused more on quoting quicker, but it happens. It works out. All right, so for this one, let's see, we have to, yeah, so you can use this range function. This is actually pretty useful when you're saying, like, you could say, if you print the range, you say print range 0, 1, 2, you say so 0, the range function takes in the initial value, the ending value, and optionally you can say the step size. Normally it's just like 1, so you say 0, 1, 2, but you could say 2 would be like 0, 2, 4, or whatever. But it's really helpful for iterating over, like, again, like pretty much what we were just saying, like iterating over the indices of a list. So you would say for I in 0 of range 0 to the length of the list. And doing from 0 to the length of the list will let you go every index of that list, which is kind of nice for iterating over that. Writing a function that's concatenating these strings, so we say def join strings, takes as input words. Let's see, we have result. So we have, n equals this name of two things, and we return the result. We're just concatenating them. So you can concatenate strings by just adding. You can just say add. Like, I didn't get this one at first. So yeah, this one's also a little bit embarrassing. You can add strings and you can add lists together. Like if you have a string of just, ABC and then DEF, you could just literally say, and A equals ABD and B equals DBF. You just say C equals A plus B, and then you'll just have one string of the whole thing. You got to do the same thing with two lists. I didn't do that here because I'm being dumb, but I'll be a little bit smarter in a second, and I'll realize that you can just add A plus B as two lists. So if I have list 1, 2, 3, A is 1, 2, 3, B is 4, 5, 6, you can just get the concatenated list by adding them together. There we go. You did it. Great job. So yeah, okay. So yeah, this is dealing with. You kind of get into more complicated versions of this, but basically lists of lists, all kinds of fun stuff right there. Basically, like we have this list. We have in first list is 1, 2, 3. Second list is 4, 5, 6, 7, 8, 9. We're just gonna iterate. So you iterate twice. We're gonna say you iterate as many times, as many levels as you need to, right? So you say for I in list, in your initial list, in this case, you would have I would be the first I that would pop up would be the 1, 2, 3. The second I would be the 4, 5, 6, 7, 8, 9. And then you would say and do another list for J and I. And then that would be for that internal list and be able to go through there. Yep. Fun stuff. Looks like we're making a battleship game. Yeah, this was just setting some stuff up. Creating as an empty list, so we're gonna populate that with something. So yeah, this is, so we're even just using this sort of append structure to just populate this board, right? So it's kind of pretty, again, useful for a lot of things. We're going to say for I in range 5, 0, 5. So that's going to just be a length, a list of length 5, but we're not actually going to see the list here. We're just going to say that references that as being, we're going to do this 5 times. And we're going to say, you know, this element of this list times 5. It'll just add them all together. You can think, remember, you can think about times as just being like addition. So we're just going to add those up together. Eventually I'll get this right, I think. Oh, there we go. Then we can print it. Defining function print board, which takes in board in. Then the first for row in board, we're going to print the row. And then we're going to print, that's our print board function, right? And then we're actually going to call it, there we go. Very cool. So this one, yeah, it took me a second. So you use this join operator. There's, yeah, so there's 2 kind of different ways, and they kind of just depends on what you're doing. If the function, like basically you can either say your object dot function and then parentheses, or your, so this is what I did here. This is what we kind of had been looking at, stuff that kind of looks like this. That was row dot join, but this is actually the opposite. So this one, the open quotations come first. So we would say quote, open quote, then dot join, and then on the inside of the join call, that's where we would say our row. So yeah, that's what I do here. I say row on the inside here, and I have this open quote here. And so that's the way. And you could say join, you know, any this is operates on a list, and we would say join it by this middle one. Another one that they have, I think, is like split, which will split a string. So you could say, like, if you have a list and you want to split it by every comma or whatever, it's similar to doing that. So we're adding, this is the random board, the random row that they're calling. Make a random row, we make a random column. Guess row, so we're going to make a raw input. So we're making these inputs for row and column. Starts taking, again, a little bit more time because I think there's like some kind of lag that goes with the guess row or whatever and the guess column. These ones are like, I don't know. You don't really ever, these are kind of a kind of common sort of Python puzzle. I guess they're kind of nice. It really is just kind of more review. Like these sort of games, they're just kind of like a default way to kind of learn. And I think if you haven't really done it before, I think it'd be interesting. There's just like nothing really new in this section. Just kind of more or less review, I guess. Look at this one. We have we're checking if this guess row and shift row are equal to that, then we sunk the battleship. Yeah. Yeah. So I mean, nothing too fancy. That's another one of those booleans. So that's one of the ones where you do need. You're writing a function, right, with if. You will need to have that double conditional using that and. So you say if guess row equals skip row and guess call equals ship call, and you can also do like and not or, and so yeah, there's like different ones, and yeah, again, in this case, this is one of the ones where you kind of have to do one of those. So we're working on it. Guess row. So in this case, yeah, so we'll need to rewrite. So in this case, yeah, if we have it to the right, we have board. So board is a list of lists. So we just sequentially reference it. So in this case, the first thing, it would be like the board 2. If it was board 2, 3, so it's a list of 5 lists. And it would be, the second one would be the second list of that list of 5. And then that one inside would be of one of those O's. Right, so each one of those is a row, and then we replace that row with that X. And so we can just reference, again, yeah, so this is just referencing the list within list. Becomes kind of a neat little structure. Now we have to write, if it goes out of the bounds, we have to say it's not even in the ocean. That's pretty badly. Yeah. Kind of double conditionals all over here. Yep. Yep, there's more and more conditionals. Adding another one to check if the spot was already hit. And yeah, another thing I guess that keep me important, it's kind of important to keep in mind where you're doing this.
like what order or whatever. So the elif, it'll go in this sort of sequential order. You'll check the first thing, and as you go down, you'll check each sequential thing. This is just testing the game, so I was just trying to run through it. Yeah, this one I kept on getting impatient because I have to press enter, and this one takes. Yeah, there you go. See, it take a while. Now I have to write all this in a for loop. So you can do this in a couple compilers. But basically, you always want to like indent a block of code that you want to run more, just indent it. And you can do that usually just by highlighting it and pressing tab. If you press shift and tab, it'll unindent. And so you can use those to actually, like I want to put this whole thing in a function, so, or whatever, or a loop, you have to indent it. So that's what I do here. I just highlight the whole thing and press tab. Kind of makes it a lot quicker than trying to indent it yourself. And most compilers really have that functionality. What's like, I mean, I guess something to keep in mind too, because if you try to like copy code, like copy and paste code, a lot of times it'll treat like tabs like in like spaces, and it's really kind of a pain. You don't want it to treat it like spaces. Like what I mean is like some computers treat four spaces like a tab, and some computers don't. And so if you have one that doesn't, and it kind of makes a difference between that and tab, you have to make sure what you're doing is the right thing. So that you should check that if something like that's coming, like indent not found or something like that. Here we have to we're checking if turn is equal to 3. So every turn, so we have for turn in range 4. So that's how we keep track of the number of turns we have. And then basically, so we have, yeah, we have like an initial thing that made this program, that made what it was to win, guess the random point. And then we had 4 guesses. So we looped over it 4 times. We keep at the end of each loop, we checked if turn was forward. If it wasn't, if it was, that was the game over. Or if we hit it, we wrote a break so that we could actually just exit and hit it. I'm definitely not going over that extra credit. I'm lazy. So these are now while loops. While loops are kind of helpful for like, you want to do something until a condition is found. So like, for example, you're training until you find some validation accuracy, or something like that. You're running until you have some specified accuracy or some specified result. And it'll could just continually check that variable. So you'll run an infinite loop if you don't change the variable that you're checking, and if the condition is it's true, or is the condition is valid. So if you say it's true, well whatever, that's true. I guess it's true. So you want to make sure that whenever you have a while statement, that you have that you're somehow modifying the variable that you're iterating through with the while. This one was weird. I still don't remember. So I had to like just put yes or no, but it didn't really accept that. I think yes. I said like, okay, well, while choice is not Y, or choice is not. So I know here I should have put the
to make it a string, so the quotes to make it a string y. But that wasn't the only problem. There was like another problem. I don't quite remember what it was. This was the time when I started really thinking about, I can't keep doing this. I'm exhausted. I was going to initially do the whole thing, but I think this is fine. 2 hours is long enough. Might end up doing more, but honestly, it keeps going on from here on out. I think this is a great exercise just to kind of go through it and just see how fast I could go. Did that work? So I say enjoying the course. So what did I actually do? So hopefully this will be the last time I restart it, but I forgot how I actually fixed this. Oh, did I cheat? This isn't glitchless anymore. Oh no. Okay. Yeah, so I just said instead of that, I just made a list. So I guess I don't know. Yeah, I don't know why that worked. But basically, you can just say, instead of making a bunch of conditionals and saying if this is not this and this is not this, you could just make a single list that has everything that you don't that you're looking for, and just say if it's in this in list. That's the conditional that you can make, which is actually a pretty useful one. So if you have like a variable and you're looking for that, if you want to say if this variable is in this list, or if this variable is yes or no, just put yes or no in the list, and then say if the variable is in the list. While if x in list will work. All right, this is going pretty fast. I'm actually not sure what I'm doing here. I was reading pretty quickly, I guess. I did a good job. Maybe it wasn't the best, and maybe some of y'all guys can do better, and I hope you can. That'd actually be pretty awesome. But I feel like I did okay, so I'm pretty proud of myself. Let's see here. So we have, so this is, so we're starting with a while our guesses left is greater than or equal to 0. We're going to increment our guesses down. So we're going to say, we're guessing a random number, that's that rand int from 1 to 10. If guess is the random number, print un, else something else, guesses left. Guesses left minus 1. So here I was deciding whether to put, I think I didn't do this right. I should have kept on going with that. But basically I had to put I didn't break here. That's what I didn't do. I should have braked after I put the new one. So again, the break will, like if you have a while loop, in this case it says, okay, well while guesses left is greater than or equal to 0, the break will bypass that condition if something happens. So it's kind of useful for if you're like searching for something, or if you're trying to find, so once you find whatever you're looking for, once you've accomplished what you're trying to do, you don't need to do that anymore. So you can just break, and that's what the break will get you out of that conditional that you're iterating over. The most recent kind of like while or for loop. I will get this eventually. I'm doing great. I'm not doing that great, but we all need some positivity once in a while. So here, yeah, instead of, yeah, you can make, that's what I should have done. I think that's right. Yeah, I put the else, you put the while, and then you say after that else. I don't think that's going to work either, though. There's one more thing I need to do. I think that's it. I think I'm getting it. You can do it. No, you were doing it. I think this is the last major delay. So if you stuck with me so far, really appreciate it. You are definitely the MVP. There we go. There we go. So yeah, I actually have to explicitly put in, which I don't really understand because actually, yeah, because, okay, so you can either, for a while loop, right? A while loop will either, you can either code it to kind of end on its own. So you're incrementing it. If you say while this number is less than whatever, if you code it to end on its own, where as you're incrementing it, it'll just naturally end, that's like one way to go about it. But you could also explicitly program your break in there based on your other, like based on the condition as well. I think it has something to do with the way like it goes back, like kind of when it repeats. All right, so here we have to prompt. We're for I in this range. It's just gonna give us this raw input. Again, we're gonna kind of do this trend of, like we're starting an initial empty list, and then we append each of the objects to that list. So we just said for I in range 2 and then or range 3 was able to get 3 items. Now we have thing equals spam for C and thing print equals spam. I think we just had to. I think this is all kind of review as well. For each in the, yeah, we were just printing out each of the individual, like just treating the word. They were asking us to treat the word like list, just iterating over it and then printing each letter at the same time at time. So now we're going to do the same thing for I in this phrase. We're going to replace a every A with a X. But we need to have this comma. Well, I'm about nearing the end. I think there's a few more minutes left, but if you made it this far, you are definitely the MVP. Really appreciate you watching. smashing that like and that subscribe. Let me know your times in the comments below, or if you have any questions, feel free to ask me. Always try to answer, address at least everybody, at least a little bit. Yeah, so I think this is overall, yeah. I mean, it's kind of repetitive, a lot of the same stuff, but that's really kind of how Python is, right? I mean, at the end of the day, it's a bunch of very basic, simple kind of functions, and they become very complicated because you combine so many of them or whatever. Very interesting. Here we're defining, so we got a dictionary. So we're just printing, what does it want us to do? Yeah, so we have to know whenever you say like for the key in a dictionary, again, just keep in mind what is the key when you say print I in dictionary.keys, right? The I is the key, and then you have to say dictionary I in order to get your actual element, your value. Zip is a kind of useful tool that will help you like kind of combine two lists together. I think coming up here. This was a weird question. I think I just had to, what did I have to do? Delete the break, I was pretty sure. I just had to delete this break, yeah. Because it was asking me to run it. So again, the break will like stop the for loop or the while loop that you're running. And this is the last one, I believe. This was just running a for and else statement. But appreciate it. Thank you. Subscribe. Check out my other channels. Really appreciate it, guys. Thank you. Bye.